the reductions of order. And this method is used when you are given one of the solutions of the differential equation of this form, which is second order differential equation. Second derivative, first one, and then the constants. And this equation is homogeneous. So once you are given one of the solutions, then you can get the second solution using this method. Okay, and don't forget that it's y1 outside here, and then the y1 is also here, but the y1 here is the square of the one that you have here. Okay, let's see questions. Yeah, look at the question we're given here. That's the question we're given. Look at the question we're given here. Okay, we have the y1, the solution for this homogeneous second order differential equation. Okay, and then we are told to find the second solution. So this is very simple. The first thing we have to do is to correspond this. So this is to the general format, the standard form. Okay, and the standard form is what is this one plus p of x first differential, and then plus q of x y equal to 0. Okay, if you look at this question, we have q of x, which is a minus 1. We correspond to that. Then p of x is not given. P of x is what? P of x is 0 in this case. Okay, then y2 will be equal to, write the formula, and that will be equal to y1 times integral e minus, check the formula. The minus could go outside if you want. Minus p of x is 0, p of x is 0 dx all over y1. Y1 is what? We have the value of y1, that will be cos h. Yeah, that will be square of that, and then dx. And don't forget, we have the value for y1. You can substitute that. My y1 is what? Cos x. Okay. Then this will be 0. Everything will be 0, and this will be 1 up there. So we have now cos. We have this equal to integral of 1 over okay, this. And then 1 over cos, that will be sec. That will be sec. So we now have y2 equal to cos. And then 1 over cos, that will be integral of sec square h sec. That will be sec square f to be this, okay, and then dx. And that will be equal to this, and the derivative of this is what? Tan hx. Tan hx. That's a y2. Tan hx. So this is the angle. This is the angle. Okay. So then the only thing you can do now is just to you can break this one down. This one is sine. This one is sine over cos hx. So this one will cancel. This one will cancel. So we have what? We have this one. The answer y2. That's the answer. Yeah, check the question. That's second differential. So we're told to find the general solution of the equation. This is second differential. This fourth differential. This is, you can see how it goes. So we need to correspond this. The solution, we need to correspond this question, correspond it to second differential plus p of x, fourth differential, and then plus q of x y equal to what? 0. So if you do that, that means you have to divide this expression by what? I'll write the expression, sine this, second differential minus q cos x minus sine x y equal to 0. So divide through the equation by sine x. Okay, by sine x. Okay, so if you divide through, then it will conform to this standard. There shouldn't be any coefficient to your second differential. And that's why we are dividing through the equation by sign x so that it will conform to the general standard. And that will be equal to second differential, if you divide, and that's minus 2 cot x. Okay, cos over sine, that's cot. Then minus this will be what? Y equal to 0. Sine over sine, that's y. So in this case now, our p of x now that's conformed to this to the standard form. So the p of x now is now minus 2 cot minus 2 cot x. Okay, that's for the p of x. So we are trying to find the second solution, knowing that y1 is cos x is the solution of the equation. So find the general solution. So if you know y1, then we need to get the y2. Therefore, then we can get the general solution. Okay, it's already homogeneous. Okay, general solution, what they mean is just the YH. So that's the general solution we are looking for. It's homogeneous. Okay, equal to 0. This is equal to 0. Okay, so y2 will be equal to y1. Y1 is what? Cos x. Okay, x over y squared, that's a cos square x. Then integral of what? Minus is there for your formula, and then with this put this minus, so it becomes plus, and that'll be 2 cot x dx for this integral, and then dx for the whole solution. So this formula we are using y1 into brackets y1 squared, and then of minus what? Minus p of x dx and then dx. So that's formula we're using to get the second solution. There is minus here for the formula, and there is minus here for the p of x. So it negates, it cancels out. Okay? So let's extract the integral of 2 cot x. So dx. You can take your 2 outside the integration, and the cot is what? Is cos over sine dx. Okay? So with that now, the derivative, the numerator is equal to derivative of the denominator. So in that case now, I have ln sine x, and then the 2 there. Okay, so y2 will now become cos x, cos x. So y2 will become cos x integral of ln. This 2 can come here. Now we ln sine what? Sine square all over cos what? Cos square x. And that will be equal to cos x. Okay. Exponential to this power, that will be equal to, that will give you integral of sine square x all over cos square x. Okay, which is what? Which is cos x. And that will give us what? Tan what? Integral of tan square x dx dx. Okay, so we don't have direct table for tan square x. So what we can do is to do the use identity. Okay, and don't forget 1 plus tan square x is equal to what? Sec square x. So we can make this tan the subject, and that will be sec square x minus 1, because there is no table for tan square x. So we can play with identity and get the integration, and that will be equal to integral of this will now become integral of tan square x is tan x, and then minus what? Minus x. So that's my y. That's the y. That's the y2 for that question. And that's the y2. So the general solution, which is the homogeneous solution. Your general solution is homogeneous because the equation is homogeneous. So that will be C1, C1, Y1. Our Y1 is given. That's for the question, cos x plus C2, and then Y2, which is what? Cos x into bracket tan x minus what? Minus x. So that's that on this question. Let's start on this question.